Welcome, aviators, to the first of 7 approaches we will be covering in your MD11 training from Angle of Attack. In this session, we will cover the VOR approach. We will be flying the VOR runway 34 approach into Zurich, Switzerland. There is nothing exceptional about this particular approach, but it will be fairly challenging, and it does involve some radio navigation, which some of you may have not done before in an airliner. It's pretty difficult. We will jump in the aircraft about 30 nautical miles north-northwest of the Bale VOR, and we'll be taking the Bale Molus 1 Zulu arrival as far as Gippel, where we will move over to the chart for the VOR 34 approach. Now, the standard terminal arrival route or star chart shows several important pieces of information. Before an arrival, you should study the charts carefully, and that is always important to do. The frequencies needed for the approach are shown across the top of the chart. There is a speed restriction of maximum 250 knots below flight level 100, which is basically 10,000 feet, and we will need to make sure that the aircraft adheres to this restriction. We see that there are altitude restrictions present at flight level 120 and 7,000 for the ZH677 and Gippel, respectively. We will need to check these in the FMS later. So there is guidance for descent planning at the bottom here, and it suggests that we be at a minimum of flight level 150 as we cross Bale. This will not be a problem at all. Now, the chart that includes the majority of the information that we'll need for today's approach is this one, the VOR runway 34 approach. Today's approach will revolve entirely around this chart, so it is important to be fully comfortable with it and commit as much of it as you can to memory. So those of you who are trainees in Aviator Pro will be familiar with the FACS acronym that we learned in the charts section, and we'll be using this on this particular approach play, and we'll be using it later too. So FACS is complementary to the full approach brief that we will cover later in the procedure. It is, however, no substitute for comprehensive initial knowledge and understanding of this chart or any chart. Complex approaches can carry significant workload, and committing the more vital information to memory is important for safety and quick thinking. Fumbling around with an unfamiliar chart is not a good way to spend your time during the procedure. You want to basically know how to fly it at that point. So before embarking on the FACS acronym, you should study the chart top to bottom and develop a comfortable understanding of what is going on. Once you've done that, here we go for the facts. Facts. Frequencies. At the top of the approach plate are all the frequencies that might be used during the procedure. These include communications frequencies and frequencies for any navigational aids used during the approach. So the frequency for Cloten VOR, which is the VOR we will be using for guidance, is included here. Obviously, you do not need to memorize all of these frequencies, but it is important to be aware of which ones might be used and be ready to look at them for reference. Altitudes. You need to be intimately familiar for all of your altitudes for this approach. This includes, but is not limited to, any altitude restrictions on the approach procedure itself, the minimum safe altitude for the operating area, high terrain obstacles such as radio towers, and lastly, the minimum altitude. This is an MDA, minimum descent altitude, for a non-precision approach, which a VOR is a non-precision, or a DH, decision height, for a precision approach. The VOR approach is a non-precision approach, as I said before, so we will be referring to it as an MDA. Of all the altitudes on this chart, the MDA is the one that should be at the forefront of your mind at all times. The MDA is the altitude on the approach by which we must be visual with the runway, or we must go around. Course. It is important to be familiar with the VOR bearings and radials that you will be using throughout this approach. In our case, the first will be 140-degree radial outbound from Kilo Lima Oscar. Our final approach course will be on the 332 bearing inbound. Terrain. Be familiar with all the high terrain in your area. In our case, there is a considerable amount, so the airport elevation is over 1,400 feet, and there is high ground to the northwest and southeast. Although we covered the minimum safe altitude when we were talking about altitudes, make sure you are comfortable with what is expected of you here. The altitudes on the approach guarantee terrain clearance, but if at any point you are unsure of your position, being above the minimum safe altitude or MSA should be one of your first priorities. Safety. It goes without saying that safety should be your number one priority at all times with no exceptions. Everything that we have covered with the FACTS acronym is geared toward increasing your safety throughout the approach procedure. To finish up your personal overview of the chart, you should be checking to see if there is anything that you do not feel 100% comfortable with. What is the MDA? What is the terrain like? Is the weather too marginal to make a safe approach? What happens if we need to do a go-around? Now is the time to get clear on those kinds of questions because you will likely not have time to think things over a whole lot when things are going wrong, unless you already know. If you get to your MDA and do not see the runway, you need to have the missed approach procedure embedded in your mind so that you can execute it safely and without delay. So this concludes the FACTS acronym. In future approaches, we will be repeating this process, but without all the explanation and clarification that we just had here, so it should be more speedy in the future. Now let's get on to the actual flying. Helping us along the way for every approach we fly will be the airbag checklist. This is a comprehensive checklist that covers everything we need for the initial approach setup. Each step is as important as the next, so memorize this one. We'll be using it a lot. ATIS starts off the airbag checklist. ATIS stands for Automatic Terminal Information Service. Today's Zurich Airport ATIS is as follows. Zurich Arrival Information Quebec, landing runway 34 VOR approach. METAR report 1730 Zulu. Wind 333 degrees 5 knots. Visibility 8 kilometers. Ceiling overcast 2700. Temperature 28. Dew point 18. QNH 1016. No significant weather. Transition level 7000. Zurich Arrival Information Quebec. I in the airbag stands for install. We will need to install our arrival and approach into the FMS, so bring up the McDo and get to the flight plan page. To enter the star and approach, we need to go to the lateral revision page for the waypoint, after which we want to modify the route. In our case, this is Bravo Lima Mike, so press the corresponding line select key to get the lateral revision page. Press 1 right for star. On this page, we see a list of available arrivals on the left and a list of available approaches on the right. We have been cleared for the Bravo Lima Mike 1 Zulu arrival and the VOR 34 approach. Make the appropriate selections, then note the Min Prof field. This appears whenever a non-precision approach is selected from this page. We will enter the published minimum descent altitude of 2,430 feet here. When all selections have been made on this page and the minimum profile altitude has been entered, press 6 left to complete the lateral revision. Let's have a look through the route on the navigation display to check it for errors. Press the Plan button on the EIS control panel to switch the ND to Plan mode. This gives us a north-up view of the flight plan and allows us to step through the route to check for errors. Our aircraft is located here. Go back to the flight plan page and use the up-down keys on the McDo to step through the waypoints. Altitude restrictions are correctly set for Zulu Hotel 677 and Gipple, but we have a flight plan discontinuity after Gipple. Because we chose not to specify a transition when selecting the approach, the flight plan as it stands wants to take us directly from Gipple to Manid on the extended center line of runway 34. We will need to construct the rest of the approach manually, so don't be confused by the magenta line already present to the east of Gipple. This is actually a part of the missed approach procedure, as we can see on the chart. We want to overfly the Cloten VOR located on the airport itself. Type in Kilo Lima Oscar into the scratch pad and drop it over the top of the flight plan discontinuity. On the duplicate names page, select the closer waypoint at the top and verify that the new waypoint is correctly placed in the flight plan. In our case it is, but we need to assign it an altitude restriction as the chart requires that we be at 6,000 over Kilo Lima Oscar. So enter a / then 6000 and drop it in beside KLO. Things are looking better now on the flight plan front, and we will leave this flight plan discontinuity in place as we will be navigating manually between these two waypoints. So press map on the ECP to revert the ND back to map mode. Now let's go to the approach page and check a few things. So press the takeoff approach function key and verify that the title reflects the approach set. Landing weight is well within limits, runway length and elevation are correct, and 35 land is enunciated. Our approach speed today will be 156 knots. R in airbag stands for radios. We would normally set up the nav radio page now, but we will tend to it later for the purposes of this demonstration, as there are a number of things to cover when we get there. So let's move on to B. B stands for brief. The approach briefing is conducted by the captain and is very important in making sure that we are fully up to speed. Alright, we've got the Zurich Airport VOR runway 34 approach. Chart is valid on the 4th of March 2009. Cloten VOR is 114.85. The first course we will follow after passing overhead the VOR is 140 outbound. At 16 DME, we will turn inbound onto the final approach course of 332. Altitude will be 6,000 feet until Manid 12.9 DME. Final approach fix is Igabi 10.2 DME. We'll be at 5,000 at this point. It is a 3.5 degree approach, nothing special, and our MDA is 2430 feet, which is 1,050 feet AGL. Required visibility is 4.5 kilometers, which is well inside the 5 nautical miles that the ATIS reported. Displaced threshold elevation is 1388 feet. Transition altitude is 7,000 feet, and the highest minimum safe altitude is 8,600 feet to the southeast of the field. MSA within 17 nautical miles is 5,900 feet. Our missed approach is a climb on the Cloten 332 bearing, then once passed overhead the radial to 5,000. At 5 DME, we turn left and continue climb to 7,000 while intercepting the Zurich East VOR's 260 radial. From there we will continue to Gipple and hold. Weather was reported as visibility 5 miles with cloud base just above MDA. There is a 5-knot wind straight down runway 34, and visibility and cloud base are pretty marginal for this type of approach. Brief complete. Next in the airbag is A, approach descent checklist. Bring out your checklist and follow through. Landing data checked as before. Windshield anti-ice. It won't be long before we descend into the soup, and while icing conditions are not forecast, it's better to be on the safe side, so use of this system will also help prevent window fogging. Decision height MDA. We need to set our minimum descent altitude for the approach, so as covered, this is found on the chart. For a non-precision approach, we will use a barometric altitude as opposed to a radar altitude for the MDA. Switch the inner knob to barometric, then turn the outer to 2430 as the MDA. This appears on the PFD here. Passenger signs on. Hydraulic panel auto. External lights as required. We will turn on landing and nose lights passing through 10,000. Descent approach checklist complete. Now for the final part of the airbag checklist, and that is go around. We covered the go around in the brief, or the missed approach in other words. Make sure you are fully ready to execute a go around if you do not see the runway by the time you reach the MDA. There is no excuse for busting your MDA. Since this is a VOR approach, we will be using VOR navigational aids to assist us. More precisely, we will be using one VOR nav aid, Kilo Lima Oscar, located on the Zurich airport. We have a few miles to run before the serious workload will start, so let's go over the VOR tracking capabilities of the PNDG MD11. Now, the navigation radios are tuned through the nav radio page in the FMS. VOR, ADF, and ILS receivers are tuned and set through this page. Two VORs may be tuned simultaneously, VOR1 and VOR2. The same goes for NDBs. ILS frequency and course are also set here. There is also provision to store frequencies and courses for future use. Placing frequencies here, then line selecting them, will place them in the scratch pad for quick entry into the VOR, ADF, or ILS fields. This can save on workload. So while we will stay on nav mode for guidance until we reach Kilo Lima Oscar, I'll demonstrate here how the VOR system works. Now, looking at the chart, the bearing that we will be flying from Gipple to KLO is 097. The format for VOR and ILS frequency entry into the nav radio page is the frequency, then the course, separated by a /. Type 114.85/097 into the scratch pad and drop that into one left. Note the magenta dotted line on the ND, which represents the course that we have set. It is possible, using the set of buttons on the ECP, to bring up information regarding VORs and NDBs on the actual ND. So we have tuned VOR1, so press the VOR1 button and note the blue marker indicating the direction of the VOR. Bearing to the VOR and DME information is shown here. Switch the ND to VOR mode by pressing the VOR button. This page basically comprises of a standard HSI. Our current heading and track down are shown at the top of the compass rose, and the magenta course pointer shows the course set. Now, the CDI in our case is deflected to the right and is slowly centering, as you can see. This means that the radial we have tuned is to our right and we are getting closer to it. The white triangle shows a 2 indication at this time. The CDI should center completely when we pass overhead Gipple, as a bearing of 097 to the VOR intersects this particular waypoint. So We are now on our final leg to the KLO VOR, so we need to get busy. We are nearing 10,000 feet, so let's configure the lights. Go ahead and switch the landing lights to extender on and the taxi lights to land. Push left and right runway turnoff switches and verify that left on and right on illuminate. Verify that the high intensity lights switch is not indicating off. The aircraft is now slowing to 245 knots automatically so as to meet the speed restriction below flight level 100. We now need to set up the nav radio page for the approach, so bring up the McDo to get to the nav rad page. If, as in this case, the VOR we want is already tuned, it is possible to enter only the course. So per the approach procedure, we want to track the 140 degree radial outbound from Cloten. Enter /140 and drop it in one left. Note the course pointer change on the ND. We also want to prepare for the final approach where we will be tracking the 332 bearing inbound to Kilo Lima Oscar. So by default, the captain's ND source is from VOR 1 and the first officer's ND source from VOR 2. By pressing the VOR switch on the captain's auxiliary panel, VOR 2 can be chosen as the source for his navigational display. This means that we can set the final approach course as VOR 2 and then switch over when that time comes. So enter 332 degrees as the course for VOR 2, and this completes the navigation radio setup. We are passing through about flight level 080 now and will shortly be passing through the transition altitude, which here in Switzerland is 7,000 feet, which you can see on the chart. It is important to understand the concept of transition altitude. Transition altitude is the altitude above which we change from use of altitudes to the use of flight levels, as you've heard me say. Now below transition altitude, we set our altimeter to show the altitude above sea level. Above transition altitude, use a standard pressure setting of 1013 hectopascals or 29.902 inches of mercury. We have been given an altimeter setting or QNH of 1016 hectopascals. Now using the barrel set knob on the ECP, set QNH 1016, and this is indicated here on the PFD. So we are now getting pretty close to Cloten, so reduce speed to 210 knots and set flaps to 15.
Slats extended.
The aircraft will level out at 6,000 feet for the pre-selected altitude on the FCP and the altitude restriction for Cloten. Looking at the ND, although it is pretty cluttered due to all the information being displayed, it is clear that we need to commence our turn to intercept the 140 radial soon. Now this magenta dotted line indicates the course that we have selected. So use heading mode to turn the aircraft to a suitable intercept angle, then switch the ND to VOR mode. We will not need to switch back to map mode again during this approach, though we might just for reference, but we'll see. So keep a close eye on the HSI. Now the blue pointer acts like a needle on a radiomagnetic indicator. It points directly to the VOR. So keep an eye on the CDI and watch for it moving toward the center. On the NavRad page, press 2 left to arm the VOR track mode. Note the VOR armed indication on the flight mode annunciator. This will change to VOR 1 when the radial has been intercepted. The aircraft will smoothly turn to intercept the VOR radial. Have a sneak peek at the map mode if you want to check our progress. The aircraft should be aligning now with the magenta dotted line. Bear in mind that our lateral guidance is being provided solely by the Cloten VOR at this time. We will remain under guidance from this VOR for the rest of this approach. So our speed will remain at 210 knots for the time being, since there is a maximum speed limit of 210 knots in the upcoming turn. Altitude is in profile mode, holding at 6,000 feet per the altitude restriction again. Vertical guidance for the rest of the flight will be provided by this profile mode. So, energy or speed management is an important consideration throughout any approach. It is important to consider just how reluctant a heavy aircraft can be to slow down. So, we don't want to end up too high or too fast on the final approach. You should plan far enough in advance so that you don't have to resort to speed brakes to slow the aircraft down. Speed brakes can provide a considerable amount of noise or vibration in the cabin, which is a discomfort for the passengers that we'd rather avoid. Granted, in our case we're flying boxes, but it's still not a great habit to get into. So we slow to 210 knots when passing overhead the Cloten VOR, which both conforms to the upcoming speed restriction and gets us slow early so that we're not rushing things. Now, we will remain at 210 knots for the moment and decelerate further in the turn. Within reason, there is no right or wrong way of doing this. Now, the decisions you make as a pilot in command might vary with the wind directions and velocities or instructions from ATC, so keep that in mind. In our case though, we will get slow fairly early to give us time to talk and be fully comfortable with the approach, since this is pretty new for you. So keep an eye on the DME indication. We are looking to start our turn inbound at 16 DME. That meaning we want to be pulling that heading knob the instant this number hits 16, or even a little bit before if you need to. So we will slow down and drop flaps in the turn and switch over to VOR2 for guidance, which we have already set for the 332 bearing inbound earlier. So we are getting close now, so set heading 332 in the heading window on the FCP. Note the dotted line indication that tells us which way the aircraft will turn. This is a useful feature and is indicating to the right, which is correct. It's very important to check this. The last thing we want is to start our turn in the wrong direction, particularly when the quickest way of getting to our new heading would actually be to turn the opposite way, or the correct way. So when you reach 16 DME, pull the heading knob to select 332, slow down to 190 knots, and set flaps 28.
Flaps 28.
We now need to switch the captain's side navigational display to VOR2. On the auxiliary panel, press the VOR button. Note the VOR2 indication on the ND. The course pointer also now points to 332. Now bring up the NavRad page on the McDo and press 2 right to arm VOR2. Verify VOR2 indication on the flight mode annunciator. As before, the aircraft will turn to fly down the radial. Watch the CDI center. Verify the 2 indication showed by the white triangle on the CDI. This indicates that we have set a bearing to the VOR. A quick peek at map mode shows us being right where we want to be. So the green trend vector is an indication of where we will be in 30 seconds, and that's looking pretty good at the moment. So as we roll out of the turn, Let's drop the gear and slow to approach speed, 156 knots. Set flaps 35 as we decelerate.
Flaps 35.
The drag from the gear and flaps will really slow you down pretty quick here. So set the MDA in the altitude window on the MCP now. 2430 is the magic number, which you should have memorized. This will allow profile mode to descend on schedule all the way down to the MDA. Once reaching the MDA, vertical mode will change to hold so that we do not descend below the MDA without disconnecting the autopilot or changing the FCP altitude. Per the approach procedure, our descent should start at the waypoint Manid. Manid is 12.9 DME from the VOR, so we should expect the aircraft to commence the descent when 12.9 is indicated here. And there we go, Prof 5000 is now enunciated and the aircraft has started descending. Now, we are aiming for 5,000 feet at Igabi, the next waypoint, and also the final approach fix. Let's run through the before landing checklist. Gear down, 4 green. Spoilers armed. Auto brake will switch that to medium. Flaps set 35. EAD, nothing of concern here. And before landing checklist complete. Let's take stock of our situation now. We are established at 156 knots, our planned approach speed, a stable rate of descent, and tracking perfectly down the 332 bearing to the Cloten VOR. Profile is the active autopilot mode and is updating as we fly through each fix of the final approach. Currently indicated is Prof 3085. When we reach that altitude, it will update to the next. So the radar altimeter has come in now, and that indicates our current height above the ground. RL callouts are given for various radar altitudes. It is an airline option which altitudes are called out. So in our case, we've got the full house. The callouts are very important later in the approach, particularly when judging the flare. So as we descend towards the runway, keep in mind what you need to be looking for out of the window. As we discussed before, it is a big deal to bust your MDA. There have been countless accidents where aircraft have descended below minimums to have a look, so to speak. If you've made a navigational error and you're not where you think you are, the ground could be right there, literally. If you forget to set your altimeter or set it wrong, you could be a lot closer to the ground than you actually think. So keep your eyes on a scan between the instruments and the window and look for those approach lights. They should be coming up soon. If you reach MDA and do not have the lights in sight, you will continue on until your missed approach point and then you will execute a go around. In our case, all we can see is a cloud, so stay alert. Passing through 1500 feet radar altimeter, the green box indication appears on the EAD. Exactly like on the takeoff, this indicates that the aircraft is configured correctly. If the terrain below is uneven, the box may disappear and reappear as the radar altitude passes either side of the minimum or maximum. I'm starting to see the lights out the window, so nothing resembling a runway yet, so keep looking. Note that since we set the MDA on the FCP profile to 2430 has remained at the top here throughout. The lights out the window are getting brighter and I think we'll make this one. As we pass through 2,640 feet, profile will update one final time to take us to our MDA. While murky, I'm seeing the runway now, so disconnect the autopilot and take her in by hand. When you take over control from the autopilot, the aircraft should be perfectly trimmed. So keep the control movements small and precise, as we don't want to destabilize the approach. We have come off the vertical profile a little high and not quite on centerline, and this is common for a non-precision approach. but we don't want to spend too long rectifying the problem, so adjust your vertical speed as appropriate and maneuver so as to set yourself up on centerline. Use the Precision Approach Path Indicator, or PAPI, to help you judge your height. 2 whites and 2 reds, as we have here, is spot for a 3-degree glide slope. So with only 5 knots of wind coming straight down the runway, keeping the aircraft straight shouldn't be a problem. So watch your vertical speed. With auto throttle active, thrust lever should begin to retard after passing 50 feet radar altitude. Flare gently at approximately 30 feet and settle the main gear
Spoilers
down.
deployed.
Verify spoilers deployed and fly
Reverse
the
thrust
nose
available.
gear onto the runway. Deploy reverse thrust and monitor deceleration. Keep your toes off the brakes and let the auto brakes do the work for you. Track that center line. At 80 knots,
80
select
knots.
idle reverse, then at 60 knots, stow the thrust reversers. Touch
60
the toe
knots.
brakes to disable the auto brakes and apply manual braking as necessary to make the next appropriate turnoff. We'll keep it fast for the moment to minimize time spent on the runway. This will be a fairly tight turn to the right, so we'll want no more than 15 knots during this turn, but ideally 10. So use what you learned from the ground operations to safely complete this tight turn. At this point, you'd be handed over to ground, or you would taxi to the cargo ramp, and so ends the VOR approach to landing. Welcome to Zurich. Until next time, throttle on.